When I say I'm a security engineer, some people ask me, what does that mean? And that's a good question. So I am going to cover what that means and what are some of the day-to-day responsibilities and some of the tools that you use. So in a role, generally, when people hire security engineers, what exactly are they hiring for? Like what are they trying to get out of this role? It depends, obviously, between different organizations why they would be hiring, but generally, it looks something like this. They'll tell you something like, help make our products more secure. And here, every word is carefully chosen. So to dig into that a little bit more, what does it mean when someone says that? So the first word is help, and then you have products, and then you have more, and then you have secure. And I want to define these a little bit. So the first one, help, this basically emphasizes that it is a support role. And in this case, you're supporting developers usually, or whoever is actually working on making the product. And then generally, like what is a product, right? And this is very variable. Now, it depends. In most companies, what does the client see when they're using that product? One example is, like, from the user's perspective, it could be a banking platform. It could be a video game, like Call of Duty is a product. It could be like a social media platform, like Twitter or Facebook. Those are products. Instagram. Now, often they are web apps, but like for example, in the game that's like a native client, it's usually like C++. But a lot of products we see today are web apps. But the product also includes the backend and the APIs, how the web app or any client interacts with the backend. And it also includes the users of the product. Those are also things you want to secure. Now, another thing we see here is more secure. Why do we say more secure? That's in contrast to saying like make our product secure. And that's the idea that it's not perfect, right? Like there's no, like, I can't say like, oh, this product is perfectly secure. That's just impossible. Everything you do is just to enhance the guarantees, the security guarantees that you have, strengthen our confidence, but you'll never reach like perfect security. And then lastly, what does secure mean? This is also slightly debatable, but generally, sometimes they mean compliant. And the reason is a lot of companies get bullied by their clients into like becoming compliant. Like for example, like a lot of startups, the moment where they start hiring more security folks is when they're about to like sign large deals with clients, like sometimes millions of dollars. And like those clients, especially a large one like banks, they'll say like, hey, like we can't sign a contract with you until you get like your SOC 2 certification. Like SOC 2 Type 2 is a requirement for us, for example, right? And so then those small startups are like, oh shit, like we need to go and like find someone that's gonna get us this certification, that is gonna get us compliant with various requirements. Sometimes it also means resilient. And I like that definition of security as a subset of resilience. And software resilience means that, like, you're resilient to what? To outages, to incidents, to downtime. Like your software just like works better in a way. as expected, right? There's like guarantees to your customers, to your clients, to your users in general that this actually works well. All of this is in theory. Now, what does this actually mean in practice in the day-to-day? There's a few different pillars, we can call them, inside security engineering. One of them is code. So the code that's being written in that organization is one of your responsibilities to look after. Then you have your infrastructure. When you're deploying code, where is that going? Where is that being deployed? That also is one of your responsibilities. And then you have the people. The people is also a good one to keep in mind, and that involves like both like your users, but also your developers, also like not your developers. All of those matter to the general big picture. And I'll define those in more detail. But I like to say that all of these together, there's emergent properties basically. One that I like to think about is that all of these create things I'm going to call events. And I'll define that in a little bit. But essentially you can think of it as like logs coming out of all of those things that we need to look at. But also when I'm breaking down like code, infra, people, that's a breakdown that I know of internally when I'm working at the company. But from a client's perspective, all of those are actually the app, which is basically runtime. And that's because from a user perspective, I'm not really thinking like, oh, am I interacting with the code now or with the infrastructure or with, it doesn't matter. As a user, I'm just using an app. That's what I want to be secure, right? So the distinction here of like, is it code, is it infra? It's actually the emergent property of all of those that is considered the app. That's what I want to secure. Like that is the product itself, right? That's what we're selling to the customers here. Now, also on top of that, something that also falls into all of those is design and architecture. So design and architecture is more of the like software development lifecycle in general. We'll talk about that maybe towards the end. What I do want to start with is the code itself first. So how do you secure code? The first thing I want to cover is the code that our own developers are writing in-house, right? So to deploy an application, we first start a Git repo. Usually we host on GitHub, and you have a bunch of developers that are like just opening pull requests and writing in Go or Ruby or whatever language we're using here. And one good way to secure code is through static analysis. And in security, we have the concept of SAST, which means static application security testing. And in SAST, that's when generally it looks something like you have a PR check that runs on every pull request, and it runs tools to check the code for known patterns of bad code, malicious code, things that can cause vulnerabilities, right? You're trying to find bugs only by looking at the code itself, right? So in the currently, but also more in the old days, we had tools like Coverity or Checkmarks or Sonar Cube, although I consider it more of a code quality tool in security. It feels like security was added on top of that later. So a lot of the big organizations use those. some of the organizations that use like C++, for example, heavily use things like covariety or checkmarks because C++ is quite complex to scan, and so these tools have their own compiler or basically wrap around the compiler, generate an abstract syntax tree, and analyze that for like a higher accuracy in the results. Those are good. They're a bit enterprisey. They generally have like an ugly UI. Takes time to set them up. Now we had a newer set of tools, a bit more modern, is semgrep or opengrep and CodeQL. Now CodeQL is a bit similar to the older ones in that it has to generate its own basically like database to query to find things in the code, whereas semgrep, which opengrep is a fork of, they can do analysis of like a single snippet, like even if it's C++. They basically you don't need to like compile the code. So if someone gives you like just a small snippet, even just a function, even just like one part of a file, and you had to just scan that, how you do it, you can just like run semgrep on it, right? And semgrep has the concept of rules. So like you can write your own rules or use other people's rules to just run those checks that the rules define. For example, there's like C and C++ specific rules that try to catch things that can cause like buffer overflow or like use after free, things like that. Now, more modern, you have the AI native SAST tools. So some folks think that this is just like running Claude. It's not quite that. Now you can run Claude to run a sort of static analysis, or although it's not really static analysis, but you can let an LLM reason through your code to identify bugs. That actually works really well. So Claude has slash security dash review, security review like that. There's a command you can run in Claude code, and they're also releasing their own like Claude security, Claude code review product as well. But so these are really good at finding bugs in code. But AI native SAST is a bit more than that, right? So generally, it's a combination of that with something like semgrep, but basically you are generating an AST, you are analyzing if a specific function is actually used in your code base or not. For example, if you have a function defined but like it's not used at all, then that's not actually a vulnerability. Now it could be a vulnerability down the line if someone does use it, but basically it's a bit more detailed than just LLM reasoning. It adds more steps and lets the LLM orchestrate and reason on top of those. Now for AI native SAST, you have tools like Corgea or Zero Path or Almanacs. Those are newer companies, very new, obviously, and they're working on AI native SaaS. I think within a few years, this will be the primary way to scan your code, because one of the challenges with static analysis is a very high false positive rate, which means that, let's say you have like a very complex large code base, maybe like 1,000,000 lines of code. When you scan that, traditionally you would find an absurd number of findings, like 80,000 findings, right? And what would you do with that? It's very time consuming. You can't just like send that to your developers and say like, hey, like, scan or like look through 80,000 findings, good luck. They're just going to ignore you forever, especially if they start looking and the first like 10 are false positives. They're going to be like, okay, like this is all bullshit. I don't need to worry about that. So triaging your findings is very, very, very time consuming. And with these AI native SaaS products, they can do some of the triage for you, or at least they can reduce the number of false positives. So it's very useful in enhancing the quality of static analysis. Now, in addition to static analysis, you also have secret scanning. So you have tools like Truffle, or Git leaks. Those are all open source tools. and you're just finding secrets in the code. Now, what is a secret? It can be like a hard-coded API key, username and a password, anything that's considered sensitive. But what is a password? Like, how can you know if something is if a string is a password or not? Um, Now there are some patterns of like API keys, but in general, some of these tools look for just high entropy strings, which is any string that I guess has like high variance in like it's like the characters like chaotic, I guess. I don't really know how to define it, but like sometimes they would, as false positives, they would flag if you have like a really long function name, because that doesn't look like any English word and has like so many characters, and so really long function names sometimes get like triggered, and it's like, oh, this looks like a secret. But generally, passwords are like long and random, and that's what you try to detect. Now, those checks, like, where are you even running them? Like, sometimes you're running them as like a Git pre-commit hook for developers so that it flags things early. But usually, you end up running them as a as a GitHub action within a pull request. Like once a developer opens a pull request, like, hey, add my code to this repo, um, it automatically kicks off some security checks. You can run static analysis. You can have like Trufflehog running as a GitHub action, and it checks that pull request and it looks for secrets, and it can flag like, "Hey, this looks like an API key. Why are you putting it here? You're supposed to put it somewhere else." Now, the last thing that I'll mention under static analysis, under code, I mean, in your code, the code that developers write is one part of it. Separately, you have the code that your developers use, but they did not necessarily write. And we have SCA, which means Software Composition Analysis. And that is the dependencies and the libraries that are used in your code base, right? So when your developers write code, they aren't writing every single line to make the app run, right? There are a bunch of libraries that are already out there on GitHub or from vendors. It's basically a bunch of code that other people wrote, and either they made available for free or they're selling, right? And usually you take that and you incorporate it into your app. So a lot of open source projects are just basically just like libraries that your developers can choose to use. Now, are those secure? Because if there's a vulnerability, that's going to affect your app here, and the app doesn't care if the vulnerable code is coming from your own developers or from a third party library. It's just going to exist on the app either way. And so that's why in software composition analysis, we look at inside the code and we try to figure out, is there anything that has known vulnerabilities in it. The most popular, I think, tool here is Dependabot. So Dependabot actually was its own company, and GitHub acquired it a number of years. It's been a few years. And Dependabot, many of you are familiar with it because you see it yelling at you on GitHub. Often it'll open a bunch of pull requests saying, hey, like this library you're using is vulnerable, you should update it. It emails you a lot also sometimes. If you have your own repo, you might have noticed that. And some vendors use other products. I mean, there's a bunch. Like Snyk is a popular one, SNYK. I don't really like it. And the reason is more that like in the corporate environment, a lot of developers might know that like it's actually quite annoying to try to keep up with updating libraries all the time. And I mean, some tools try to like automate the updates for you, but there's always a risk. You always risk breaking something when you update. And one of the problems is just like it's overwhelming. Like there's always something to update, like every day, all the time. And what ends up happening often is just an infinitely growing backlog of things to work on, things to fix. And so they end up getting forgotten. And then you have this like app collecting like thousands and thousands, tens of thousands of vulnerable dependencies and libraries, and nobody's doing anything about it. I think here, ideally, you have some sort of like agreement with your developers of like, we should try to update dependencies semi-automatically, like at least once every couple of weeks. although some might consider it a bit idealistic. Now, another part of SCA, you might have heard about SBOM, which is a software bill of materials. It is related, and it's basically like, what is inside my code? This is my product, but like, what is it composed of? Like, what are all of the different pieces in it? Like, some pieces of code are mine, some pieces of code are like from these other like vendors or open source projects. And some people care about like the licensing, like because open source software is licensed in different ways, and that can have like legal implications of how you can use and sell your product. So all of those things are part of the code itself. Where's your code being deployed? Your code is being deployed on infrastructure. Now, a few years ago, that meant often like just like a bunch of servers in your basement, and you had to deal with that. Now that's not really common. I mean, still, some banks or like people that have like old school infrastructure, they still host their own infrastructure in a basement or wherever in their own data center, data warehouse. But now often this means cloud. And cloud security is a role that's a subset of security engineering. So when you talk about cloud, you have CSPM, which is Cloud Security Posture Management, and that is basically your Wiz, your Prisma Cloud, and it also includes some native security tools or platforms like AWS has Guard Duty or Security Hub, and those are in AWS itself. Now GCP and Azure and the cloud providers, most of them have like some built-in monitoring capabilities a little bit. A lot of companies do use Wiz or Prisma. Those are like the two main cloud security posture management tools. And the idea is that when I'm using a cloud environment like AWS, was it configured securely, right? Are there any important things happen? Like, what's a bad things happening there? Well, how would I know? Well, what are some bad things in my cloud environment? One example is misconfigured S3 buckets in AWS. Often, I mean, it depends on the use case, but often you want those to be private. And there's a few that are meant to be public, right? And so a mistake that has led to incidents in the past is you take an S3 bucket that's supposed to contain sensitive information, PII, like private information, and it ends up accidentally leaking it. And the bucket ends up being public, configured to be public accidentally. That's something that you should get notified of as soon as possible, right? And these tools, they can send you an alert saying like, hey, this bucket is public. Is that normal? Is that supposed to happen, right? And then like if it was accidental, you can immediately catch it, ideally before anyone else does. I believe this was one of the there was like Capital One hack like a few years ago, and I believe that was what the issue was, that like it was a public S3 bucket that had personal information in it. And it wasn't supposed to be public. So monitoring your cloud environments is a big one. Now, the configuration of the cloud environment itself is one thing. Now, the cloud environment, what is it used for? It hosts infrastructure, right? So when I want to deploy it to a server, what is a server? It's usually just a Linux machine. Where is that server hosted? If it's not in my basement anymore, now it's in AWS. It's in Jeff Bezos' server farm, or in one of them. And so how is infrastructure configured? Now, often we use IAC, which is called infrastructure as code. Code, I mean, arguably you could put it under the code section, but that is Terraform. Usually we write Terraform that basically defines like, hey, this server needs to have these ports open. It needs to be Ubuntu. It needs to have like this volume attached to it with this many gigabytes. Like you're defining all of that, but you're describing it in Terraform. And instead of like having to click to set up infrastructure, right? And you also have containers or container images, and those often get deployed on your servers, and they also have like the set of packages that you would need to make that service run. So you have tools like Chekhov, and you have like a bunch of like container scanning container image scanning tools that are supposed to list like known vulnerabilities in your code. There's a few like Terraform scanning tools, and they look for like common misconfigurations or like known vulnerabilities in your container images. The container images, again, they have to be updated as frequently as possible to avoid known vulnerabilities in them. Now, how does code get into infrastructure? Usually you have CI/CD pipelines, continuous integration and continuous deployment, and that's basically the pipeline or the set of automation that takes your code once it's deployed, like takes your repo from GitHub, usually through a GitHub action. But you used to have like things like Jenkins to orchestrate that, and they deploy it on the relevant infrastructure so that it's now hosted on the internet. So your CI/CD pipelines are also something that I would want to look at to make sure that they are configured securely. They're not leaking sensitive information accidentally. One example is you could have like a set of like files in the repo that are not meant to be deployed publicly on a server, and your CI/CD pipeline could basically strip those out to only deploy the actual code and not like things that may include environment variables or other configuration files. Now, also part of infrastructure, I will actually use a different color for this, is corporate security. Now, corporate security, what does that mean? It's kind of like IT, but the security side of it. Everything that IT does, we work with them to make sure it's secure, but you also have your own security tools. So, for example, the first example is EDR, endpoint detection and response, and that's your CrowdStrike or Sentinel-1. Those are maybe like the two most popular. And that's essentially like, is there malware on my employee's laptop? That's something we want to know about. So configuring endpoint detection and response (EDR), that's a big part of your corporate security responsibilities. And the assets themselves are relevant, but also vulnerability scanning. So like Tenable or Rapid7, those basically are scanning your environment. So both, like they have agents on your laptops, on all of your employees' laptops, where they can report on like outdated software packages, but they can also scan your servers as well. And the goal here is to tell you if there are vulnerable packages being hosted on your servers. And ideally, you want to know if anything is exploitable. Especially if it's publicly exposed. Like if I'm publicly exposing a service on a specific port, is it hosting a software package that is vulnerable, is exploitable, right? And if it is, I would want to update that. So vulnerability scanning your infrastructure is also a responsibility. So it can have agents on your infrastructure, or it can have like scanners that like blindly scan. Another thing is secrets management. Secrets management, like for example, you would use something like HashiCorp, Vault. That's not necessarily under corporate security, but it doesn't matter. But so some of your services would want to access secrets. For example, your CI/CD pipeline sometimes. And so you would set up a solution for your services to fetch those secrets and store them securely. Another one is email. So in email, you have like DKIM, DMARC, which is like DKIM and SPF. So if we're sending any emails from our corporation, are they gonna get marked as spam? And so you have these security mechanisms, DMARC, DKIM, SPF, which are essentially they're like DNS records that you have to add on the domains that you intend on sending email from. And they specify, like SPF, for example, says like these IPs are allowed to send email for this domain. It's supposed to be a way to catch spam. But configuring all of these records and making sure your email is deliverable, that's sometimes falls under security responsibilities. And lastly, your office Wi-Fi, or like things like VLAN segmentation, like your office infrastructure itself. That's also part of the things you'd want to care about. Is the office Wi-Fi secure enough? Oh, actually, you can also do things like VPN. Is that configured correctly? Or can my employees use VPNs? So the third one, and this one I feel like people seem to miss sometimes, is the people. And the people here means many different things. So the first part is my employees, not necessarily just developers, right? It can be developers. It can also be like non-developers, like HR, my CFO, right? If my CFO gets phished and someone accesses their account and then transfers money or something, like that is a pretty bad security incident. And I would like for that to never happen. So trying to make sure people don't get phished. I'll add that here. I mean, it could be under corporate security as well, or email security. But anti-phishing is also like a lot of training as well, so it's very much a people problem. So training awareness. But other than your employees, it's also your users. And for example, you're worried about ATO, which is account takeover. I'm very much responsible if all of my users get hacked at the same time. That's bad. It doesn't really matter why, like even if they have like malware on the machine, like that's still something I would want to detect and prevent, right? So trying to detect when my users or employees have their accounts taken over, like, oh, did everyone suddenly log in from a new IP at the same time? Is anyone trying credential stuffing? Like, for example, are there like 17 failed login attempts succeeded immediately by a successful login attempt? Then someone's guessing passwords. Ideally, that should be something I'm aware of, alert on, and ideally maybe even block the account. So bad things happening to my users or employees, that's important to know. Then I have roles, permissions, which generally we called IAM, identity and access management. Very important. How are they configured? Are we following the principle of least privilege? And that's both. Like it's permissions for my employees, but also for the users of my app. Right? A lot of apps have the concept of different permissions and roles. And so, for example, if I have a banking app, the admin role should be guaranteed to be a different set of people than like the normal user of the bank app, right? Not everyone should be able to log in as admin. So identity and access management, that also technically applies also in your cloud environments and everywhere else really. So authentication and identity providers, like for example, like Okta, um, that also you want it to be configured correctly, like things like SSO, single sign-on, like all of those is take a lot of effort to maintain and configure correctly. Another thing that falls under here is DLP. It's something I do not really enjoy working on, and that's data loss prevention, and that is basically corporate spyware, unfortunately. And the reason security teams implement it is well, it's partly for compliance, but generally, like, what if one of your employees dumps dumps your entire database or client list or like a list of like 1 million social security numbers that your company has and just like emails them to their personal email? That's not very good, and that's generally something you would want to alert on. And so DLP, to prevent this sort of data loss, you basically have to do some spying, unfortunately, and that means terminating TLS introspection to like decrypt some traffic and see what they're actually uploading. Like, is someone uploading something to Pastebin that has a lot of PII in it? That's something that you would alert on. Part of it is also like introspection into your like Google Drive and like other cloud services, Slack, to also detect like large amounts of PII. Generally, it's what people care about, and a lot of that falls under GRC. Now, that's not necessarily under people, but like I'm gonna put it here for now. GRC is governance, risk, and compliance, and that's like your auditing. Like when you have like a yearly audit for SOC 2, like are we compliant? It also includes like vendors, third party risk management. So whenever we are onboarding different services that like anyone in our company wants to use, like, is that service safe? to use, because similarly, like if I onboard like some sort of tool that's running on all of our laptops and that vendor gets compromised and now everyone can go log into our laptops and steal data, right? So I would be affected. So third-party risk management, reviewing the vendors we use and the services we use from third parties, that's also part of security as well. Now, the reason I said that all of these lead to events is essentially that the code, the infra, the people, like authentication logs, like everything that's happening in here basically generates logs. And whenever anyone says logs, you think about a SIEM, which is generally Splunk, but it could also be an elk stack, which I think is called like Elastic Stack now, which is Elasticsearch, Logstash, and Kibana. That's like a free, usually, version of. So Splunk is very expensive. But first, I'll define it. What is a SIEM? I think it stands for Security Information and Event Management. But basically, every single event or action that's happening here generates a log, a line saying like, this person logged into this platform at this hour, and it goes into your SIEM. And the reason is that's how I would know that a bad thing happened, right? So services like Splunk, their job is to collect my logs from my infrastructure, from my deployment, from my app itself during runtime as well, and from, authentication logs of my employees, everything really. Well, not everything, everything that can generate a meaningful security event that I would want to know about. And then you set up monitoring rules on top of that. So Splunk has its own like querying language, but like each SIEM provider I think also now like things like Strike also has its own SIEM now. A lot of vendors now are making their own, but they'll all have like minor variations of like how exactly can you query for certain events. But that's how you can set up things like alert me when for any user there's like 10 consecutive failed login attempts immediately followed by a successful one. You would define that as a rule in your SIEM, and you would get it to alert you on, let's say, like Slack or by email or whatever. And that's how you would know, and you would respond. So IR or SecOps, incident response or security operations. Some people consider them part of security engineering. Some people consider them separate. Doesn't really matter. But generally, who's responding to those events? Especially when the event turns out to be actually bad things happening, we need to contain that. That's instant response. You might also hear the term SOC, Security Operations Center. Now, some companies, large companies, have like in-house, like a full team that's a SOC. Sometimes there's no team that's a SOC. Sometimes it's an external outsourced SOC, but those are basically generally like someone looking at all of these alerts that are being generated and like, is this bad? Is this worth responding to? Is this an incident? Sometimes you just have one security engineer, and that's the person that has to be also like on call or just like acting as a SOC analyst, looking at the alerts, determining what's happening and why, and is it actually bad. Generally, I'm not that big of a fan of external SOCs, the ones that are like managed by a third party, because they don't really have as much context into all of the other stuff, right? Like ideally, if you're here, you also want to understand all of the other stuff, like where are those events coming from and why, to really make sense out of the logs. But often, like the mistake some people do is like they'll hire like an external SOC, and they'll be like, "Hey, tell me if this alert is bad," but then they won't give them access to anything else. And so it's like I'm just seeing like a random alert, and I have no idea if it's good or bad. So it's not very effective. You might also hear about detection engineering, which is similar to SecOps, but that is like, someone responsible for setting up all sorts of detections in your environment. That can also include honeypots, or deception engineering. And so like if I want to catch attackers in my network, one way to effectively catch if bad things are happening, if set up something that's purposely meant to like never be touched. And if someone's touching it, that's weird, alert us. One example is like setting up a Google Drive that says like, hey, this is a credit card number and a list of passwords. Because attackers, if they phish you and get access to your Google Drive, they'll often look for CVV or anything that looks like a credit card. And so setting up a fake credit card that's searchable can often catch attackers. That's a honeypot. My favorite vendor for that is Thanks Canary. I have an interview with their founder, Harun Mir, on this channel. Really great guy. So yeah, response, security operations. One thing that's relevant to all of that is generally data engineering or security of your data in general. So telemetry from all of your infrastructure and your app as well, and like and anonymization, like sometimes like scrubbing sensitive data from your logs and is important part of your process and workflow, because like some of your logs may contain sensitive information that you don't actually want to save into your SIEM. So scrubbing and making sure your logs are sanitized is an important thing to keep in mind. Part of generally events is ASPM. Now you could also put that under code, but ASPM is Application Security Posture Management. It is very closely related to the code section. So some of these tools all generate findings. Where do those findings go? So as I said, one of the challenges is like, you scan something, it generates like 80,000 findings for just like one app. Well, what if you have multiple apps and you're scanning it with multiple different tools like SCA and secrets and maybe like vulnerability management here. And so application security posture management will be like one platform that aggregates all of these findings and helps you like correlate different findings and like really know the attack surface of a single asset or product or service. And you can triage there because you have like a single pane. There's also many different vendors. Current, like GitHub, I think they're making their own SPM platform as part of advanced security. None of them are great right now. I haven't seen one that I really fell in love with. I think maybe like Aikido is probably like a solid one. They're adding a lot of features, including doing some of the scanning stuff we mentioned. Um, But with AI, I think we'll see a lot of better ASPM platforms surface. Generally, you also have security workflow automation, like GitHub Actions that trigger. I mean, that could be anywhere here, but where are all of my events coming from? How is automation going? Like, what's like tying everything together? And finally, you have SOAR, um, security orchestration, automation, and response. But that's like you could like automatically trigger an action when once certain conditions are met. So some of your SIM platforms can support that natively, but essentially it's like you can say like one example is like, oh, if this S3 bucket is ever accidentally made public, just immediately take this action to make it private again. That's one example. All right. So, when this condition is met, when this event happened, immediately go and automatically take this action to mitigate that threat. Right. So SOAR is good on paper. It is actually quite challenging to implement because you need a well-defined small action to do that you really have confidence that it's going to do the right thing. I've heard some like horror stories of like SOAR going wrong and accidentally like deleting S3 buckets or like because of a bug or like acting on false positive alerts. Um, Actually, in general, reducing false positive rate is a very important part of your role, because false positives will just occur everywhere, and so that's like events that trigger that aren't actually a significant security event, and so ideally here you spend a lot of time like um tuning alerts, reducing noise basically to make sure that you're alerting on the right stuff, because looking at alerts is tedious, it's costly, and you can see um, reducing alert fatigue. Like alert fatigue, like it can cause issues in itself. there was, I think, the Target breach, maybe like back to 2013 or something, but Target was breached and they looked like, hey, how come nothing alerted us of like, if bad things are happening? And turned out like they were getting alerts, but they were also getting like tens of thousands of other irrelevant alerts at the same time, which made it like really impossible to identify the signal from all of the noise. So that's an important part of the job. All right. So given that we cover all of these, now I want to spend some time on the app itself. So all of these are like your internal inner workings of like what's happening at your organization. But from an external perspective, as a client, as a customer, I'm just logging into an app, using it, and I want it to be secure. Could be a mobile app, could be a game, doesn't matter, whatever it is. So what are some things that are relevant specifically to the app at runtime, really? So you have a set of checks here as well. So the first thing that I want to mention is DAST. So that's in contrast to SAST. SAST is static application security testing. D for DAST is dynamic. And that is basically like, instead of like looking at the code line by line, something that's like doesn't change, I'm looking at the app directly. And why do we do that? Because when we're looking at the code, we're identifying some issues and we're assuming that those are going to make their way into production and get deployed. But there are many different variables that come into play. And what actually is deployed in production? Is it always like that same code itself? Did I inject any new vulnerabilities through dependencies or in other areas of my pipeline? Or maybe I deployed the wrong version of the app. Right? There's so many assumptions that we can make here. And the idea is like we don't have to make assumptions. We can just check what's actually going on in runtime. And so we use dynamic analysis for that. Now, DAS tools are generally not that good for like good signal. Often they just give you low quality findings or false positives. At least that's how it was, but they've recently improved massively. Now, tools you can use is Zap. It's an open source tool. You can even run it as a GitHub action and automatically get it to scan like periodically on a cron job or like after changes. Burp Suite Enterprise. So that's different. They have like, I believe it's a separate offering where you can run DAS scans. Now, technically the Burp scanner, they have an active scanner you can run within Burp itself. That's like DAS, but they also have like one you can run in CI/CD or like automate like running. It's more enterprisey scanner that you can run in your infrastructure. I think some vulnerability scanners like Tenable also have like a web app crawler, like a DAST product to scan your web apps. What's more interesting is this has more recently changed with AI DAST. So basically like AI pen testing. And those have been quite promising in general. And so they're you know how I mentioned like traditionally you would get a lot of like low quality findings and lots of false positives. Now with the AI versions of those pen testing tools, it's kind of like having like a bug bounty person just like looking through all of your apps, and you can just like let it run. And so they have to be configured correctly. You have to give them credentials. You have to make sure they're able to like reach all the different flows in your web app. But a lot of these AI pen testing tools have been finding good vulnerabilities in products, and so that's been quite promising, and things have been improving in that area. We should always also remember, like similarly to how we mentioned vulnerability scans for our infrastructure. Here, we also have to validate like firewalls, or like exposed services. So for example, like, you can run Nmap. Sometimes it just helps to have like Nmap running as a GitHub action on a cron schedule, maybe like a couple times a week, just like to poke at your internet facing assets and be like, hey, like, is there any like crazy port open with something that I don't expect? Sometimes you'll find that, oh, actually this IP no longer belongs to me. That's why it's showing different things. But ideally you automatically update it to use your actual IP addresses. So yeah, here in general, you want to guarantee that like during runtime, what I'm actually running is what I think I'm running basically. Now another part here is design and architecture, and that's kind of like the more just theoretical part of security engineering, and so let's talk about that a little bit. So you have SDLC or SSDLC, which is Secure Software Development Lifecycle, and basically you're working with developers, right? And so the relationship with developers is a very, very important part of security engineering. So your developers and SREs and like anyone working on the product in general, you can work with them to ensure that the life cycle of the software itself, like how are they developing, how are they following any guidelines, how the whole process of making software has to be like considerate, like you've thought about things, your defaults are secure, there's like solid guidelines in general. So presentations, metrics, I mean those are all things you're presenting to the rest of the org, to maybe like leadership, to the board, to the like you're proving that like your security program makes sense. We also do threat modeling. So in threat modeling, um you have Adam Shostak is one of the like the most prominent figures in the world of threat modeling, and he has his 4 questions, which is like the best guide I've seen for threat modeling. Generally, it's something like, what are we working on? What could go wrong? What can we do about it? And did we do a good job? And that's really what threat modeling is. Just like taking a moment to just think about those things. And I mean, there are different philosophies on like how you're supposed to do threat modeling. Like, is it the responsibility of the security team solely, or is it solely the responsibility of the developers? It's both. The best people to do threat modeling are your developers, are your system architects, the people who have designed the system, because they can really think about what could go wrong, but you can also work on it with them to guide them through scenarios. A, a big part of this is making sure that we're not making assumptions that are wrong or could get invalidated later. Sometimes like documenting your business invariance is a good part of this. Threat modeling is a part of like just design and architecture in general, and usually you want to do it as early as possible in the process to make sure you catch things early and that things are designed safely. And so let's zoom out. Yeah, I mean, I think this is basically everything. That's what I consider to be security engineering. I mean, there are some like nuances here, and some people think like, oh, security operations is not part of it, or some people might like add more things to this in general. But generally, when someone hires you as a security engineer, and that can include AppSec, product security, cloud security, like it's either all or part of this in general. So to recap, what is security engineering? Typically, they hire you to help make our products more secure. So it's a support role. What is a product? It could be a web app, a native client like a video game, a mobile app, a social media platform. All of them work with a backend using APIs, using different interfaces, and more secure, more because it's not perfect. You're just improving. And what is secure? It can mean like compliant or resilient, or like just help us not have bad things happen. The first part is the architecture and the design as early on as possible. You want a threat model. Then you have what's actually running in runtime. So you use dynamic analysis. You scan what's actually deployed. Then what consists of a product? You have the code itself, the libraries that the code uses, the infrastructure the code is being hosted on, the assets that your employees use, the employees themselves, the users of your apps, and the roles and permissions that are defined for them. And all of those generate events that we have to monitor continuously and look at and alert on and know how to respond when a bad thing happens. And it will. And usually it's going to be phishing.